T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T minus 10, 9, 8.
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
T minus 10, 9, 8.
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
À tous de l'EDO, attention pour décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Allumage. Décollage. Les pressions foyer sont normales.
It looks like another mission to planet Earth is on its way.
Yes, Jack, we started at 320 tons. And at
Extinction des propulseurs d'appoint.
well, here goes the solid boosters.
T minus 10, 9, 8.
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
Topex Poseidon is a satellite mission. It measures the precise height of the sea surface, we call ocean topography. This ocean topography is the pressure of ocean currents. So scientists use this pressure information to compute the speed direction of ocean currents, pretty much like a meteorologist to compute the direction and speed of winds from weather pressure maps. The ocean is important because it is really the largest repository of heat and carbon dioxide of this planet, the two most important ingredients affecting climate change. In order to understand how climate change, both in near term and in long term, we'll have to understand how ocean changes. So it's very important to study the ocean. Topex Poseidon is an outgrowth of a serious effort, beginning with the CSAT, the first ocean satellite launched by NASA's Jet Propulsion Laboratory. After the success of the CSAT, people in the United States understood that we can measure the precise shape of the sea surface, the ocean topography. And the French scientists also have similar ideas at the same time. So in 1983, the two sides combined forces and formed the mission called Topex Poseidon. The measurement principle of Topex Poseidon is relatively simple. It utilizes a precision radar to measure the altitude of the satellite above ocean surface. In the meantime, the satellite carries a number of tracking devices, allow us also calculate precisely the location of the spacecraft in space. So from these two measurements, we can determine the height of the sea surface very precisely relative to a coordinate fixed on Earth. So this computation gives us ocean topography that allows to compute ocean currents, heat transport, and so forth. Topex Poseidon was designed for flying for 3 to 5 years. But because the measurement is so challenging and the importance of the results, the mission was designed to have redundancies. It has primary instruments, every primary instrument has backup. So that's why we can stretch the mission from 3 to 5 and now to 10 years. And as today, the system is still healthy, and we anticipate it can run for 2 to 3 more years, barring from any unforeseen situation. The most important contribution of Topex Poseidon is the creation of a new way to study the ocean. The results have revolutionized oceanography like weather satellites did to meteorology 30 years ago. For the first time, we have a continuous 10 years observation of the ocean, allow us to study ocean changes from weeks to months, from years and now to a decade. We have seen transformation of El Nino into La Nina and even longer term change in the ocean. And these results allow us to create new theories and models of dynamics of the ocean that govern the change of climate. So the scientific payoff is tremendous. The ocean is such a vast domain. In the past, we rely on ships to measure oceans, and it's slow, and the data return is small. Just in one 10-day cycle of Topex Poseidon, the amount of data collected is equivalent to the past 100 years ship measurements. So now we have 10 years, so you can make the calculation. Topex Poseidon measures ocean currents that carries heat and dissolved carbon dioxide in the ocean. This exchange of heat and carbon dioxide between the ocean and atmosphere allow us to calculate how the climate will change as a result of ocean changes. So that's why we can study climate change in ways we've never been able to do before. The ocean changes very slowly and also on a scale as large as the ocean basin. In the past, we do not have measurements that allows us to watch how the global ocean changes over a long period of time. Topex Poseidon allows us to observe how transformation of El Nino to La Nina and into decadal oscillation takes place in the ocean in real time. So this is the first time we can calibrate ocean models that help us predict these phenomena better. Topex Poseidon have watching the ocean constantly. Since last summer, there are several attempts of the ocean to create El Ninos because we have seen a series of so-called Kelvin waves from the West Pacific carrying heat to the Eastern Pacific. And as we speak, there is a Kelvin wave going on right now. It will reach South America in a few weeks. Inevitably, that will raise the temperature there by a few degrees. So the mild El Nino prediction is probably correct for this coming winter. A very important discovery of Topex Poseidon is the role of tides in ocean circulation. We know tides for centuries and even thousands of years, but we never knew the close link between tides and ocean circulation. And Topex Poseidon discovered that the dissipation of tidal energy in the deep ocean is so important to shape the state of the ocean and the circulation. So we measure tides very precisely from the mission, and that in turn benefits our goal to determine ocean circulation. Topex Poseidon is producing tremendous useful data. For the first time, weather agencies actually use satellite to improve their prediction models. So the El Nino prediction of 1997-98 was improved, in part due to this new capability. And we also improved the offshore currents prediction and benefit the oil industry because they rely on our information to plan their offshore operations. And also yacht racing get information from Topex Poseidon to take advantage of swift currents to cut an easy route. A fundamental impact of Topex Poseidon is the transformation of oceanography from an exploratory science to a quantitative science. In the past, we send ships out to find out how the ocean behaves. Now we take measurements and feed into computer models and actually compute what will happen in the future as well as in the deep ocean. So this quantitative usage of the information is the future of oceanography that will have much more benefits to the society than we have done in the past. Topex Poseidon brings us a new capability to study the ocean. JSON-1 is a continuation of this new capability to benefit future generations. After JSON-1, we will launch a mission, the Ocean Surface Topography mission. That mission actually will transform this research and development mission into so-called operational mission, which should be there all the time, be part of a permanent observation system for the ocean. And this is very important. That's why the Ocean Surface Topography mission is a four-way collaboration. In the United States, involve NASA and NOAA. In Europe, involve CONES and EUMETSAT, the European Weather Observation Company. And our hope is that we will be able to bring this remarkable new technology into a permanent facility to benefit future generations.